Welcome back to the See It in Action demo series.
Alright, for this demo, I am going to demonstrate how to migrate my entire Windows server from a VMware environment to Apache CloudStack with Cirrus Migrate Cloud. This is the environment. First, I have this 2016 SMB Windows machine here running on a VMware server as our migration source, with 8 GB of memory and 2 CPUs, 3 disks, 1 20 GB boot drive, and 2 1 GB drives. Note that our migration source can be any environment and any block storage solution, whether physical or virtual, across any hypervisor, private cloud, or public cloud platform. CMC does not actually care what environment your source host is running on. Even older versions of virtual machines from other VMware environments that do not support native migration can be seamlessly migrated using Cirrus Migrate Cloud. Connecting to it, I can see that this is a 2016 Windows server running on VMware with an Intel CPU. Under disk management, we can see the same 20 GB boot drive and 1 GB E and H drives, and all of them are VMware VMDKs. We are migrating from VMware for this demo. As for the destination, I will be migrating to our CloudStack environment. In this environment, we have a project P1 running on the root domain in our zone Z1, which is our test zone. We currently have no storage volumes or instances, and we will be migrating our Windows machine to run as a virtual instance here. Let's go to Cirrus Data Cloud. You can see all these Linux and Windows hosts already registered on this project, and I will use this machine 2001 acting as an access node for this migration, but when you do it, just any host on the same network will work just fine, and I will further explain this access node concept later as we will apply it in our migration configuration. Now I am going to deploy Cirrus Migrate Cloud on my host by copying the installation command and pasting it in the shell. CMC will install and register to Cirrus Data Cloud all by itself. This same installation command can be used on as many hosts as you want, so you are free to use any automation mechanism of your choice to deploy Cirrus Migrate Cloud at scale. The migration process of Linux hosts is more or less identical, and all you need is to install with a different installation command. My Windows 2016 SMB host is now displayed on the registered host list, meaning that the installation is completed, and we can see the 1 GB data drives and the 20 GB boot drive. The CEH drives here under our registered host details, which is the same as what I had here, and they are VMware virtual disks. Before I continue to show you the next step, let's briefly look at MigrateOps. That is a purpose-built data mobility as code automation platform that is designed to make data migration in enterprise scale easier, safer, and more predictable. This is an automation platform that optimizes global data mobility beyond just storage to storage data migration, thanks to the flexible automation capabilities that work with your operating system, applications, or even cloud infrastructures. It enables seamless chaining of functionalities with other automations that are often managed externally, such as OS automation, application automation, public and private cloud platform automation, virtualization platform automation, enterprise storage management automation, SAN management automation. Normally, we would come here to create migration sessions manually, but for this scenario, we will use MigrateOps. Let's take a closer look. Here, I want to show you the purpose-built MigrateOps recipes for all the scenarios you need. I am going to use this new Compute Migration to CloudStack recipe for this demo. From here, I am able to view a complete guide and configuration reference for detailed instructions to operate MigrateOps for migration to CloudStack. One particular option I would like to point out is the need for a CMC helper. This is a temporary VM that is automatically deployed on the CloudStack environment by Cirrus Data Cloud to assist in the migration process. You don't need to worry about deploying or managing this since the system handles everything by itself. Once the migration is complete, the VM is automatically cleaned up, so we need to upload the VM image to the environment for MigrateOps to work accordingly. Most importantly, your data always stays within your 4 walls. It comes directly from the source and never leaves your data center, ensuring complete security throughout the process. For the helper VM image, we'll use this URL to register the template. Let me show you. We come to CloudStack and register a template. Paste the URL and give this a name, CMC Helper VM. Select a zone. Select KVM for hypervisor. Format QCOW2. Choose your OS type, and direct download is off. All other fields are optional. Boom! Our CMC Helper VM template is now available. If you have a different configuration, you may specify it separately. And now let me set up the integration for the next step of this demo. Under hypervisors or private cloud integrations, you can find the CloudStack integration. I will proceed to add this integration with a name, the endpoint to our CloudStack API server, our API key, which we can copy from here on CloudStack, and the same thing goes with the API secret, and verify the connection with any of my hosts in the same network. You only need to do this once, no matter how many VM you need to migrate. Now that I have CMC installed and the integration ready, let's move on to create a new migration operation. In this scenario, I am migrating this Windows 2016 SMB, and I am using this ST Ubuntu 0.20.01 as my access node as I mentioned before, because we need another node within the same network to access your CloudStack environment, which is private. It can be any Windows or Linux host or any of your source host. Next, I will drag my configuration file right into MigrateOps. Like many other industry-standard automation tools, our configuration is in YAML syntax. For this demo, I already have a YAML file prepared. And of course, while I am creating the configuration, I can always come back to the MigrateOps reference to apply all the fields we need. Let me show you how it's done. I am providing an operation name, the recipe that I am using, which I can find the recipe ID from here, the specified host name and integration name that we have set up earlier, and this is our system name, again from the reference. We will be able to find the integration name or ID that we need. Project P1 and Zone Z1. My access node Ubuntu 20.01, and my compute configurations. When we look at our compute configurations from our MigrateOps reference, there is a service offering for configuring instance sizes, and from CloudStack, we can customize compute offering. Cirrus Data supports both fixed and custom offering. It is important that we would need a custom offering since I want to specify the number of CPU and memory I need on my new environment. If I don't specify a field, CMC would still automatically detect and create an instance for me that matches the source environment. But in this case, we want to make sure that this VM only has 2 GB of memory and 2 CPU, because unlike our VMware environment, this CloudStack demo environment is much smaller. We also need a disk offering, so I have already created one from CloudStack to get it set up, and I will take the disk offering ID from here instead of the name because it is not unique in our case. Cirrus Data offers a comprehensive range of MigrateOps recipes, supporting migrations from a variety of environments. No matter which platform or storage you are migrating to or migrating from, the process is more or less similar. This is the completed configuration. Note that this is just for one host. You can add as many hosts as you want into your configuration. But for now, let's keep it simple and submit this configuration for this demo. The migration operation has started. Once I enter this newly created operation, I can view all the details. The operation has already identified the access node with all these messages, and it has also validated the compute configuration. This is going quickly. Next, it has created the migration instance. It detected the specifications from our source VM, and since we specified a reduced memory, it will apply that change to 1 CPU and 2 GB of memory while maintaining the other settings. Moving on, our virtual instance has been created, and we can already find the MigrateOps instance running here on CloudStack. Data goes directly from my source VM to this VM. So again, nothing comes to our cloud as the data never leaves your data center and always stays within your 4 walls. It is a direct, optimized, and encrypted channel. And so far, all of these actions are automated. Moving forward, the CloudStack instance is deployed and registered with Cirrus Data Cloud. The H2H connection is created so that we have a secure data transfer. This is the direct connection from our host to our temporary host. The destination virtual disk storage is prepared. From our source, we had the 20 gig boot drive and the 2 1 gig data drives. And now from CloudStack, we have already created the hard drives, and we have the same drives created by Cirrus Data Cloud. A migration session is created and data is synchronizing. Let's go and look at the migration session details. The CEH drives are migrating from VMware to the CloudStack environment. We can track the progress with the change data map. The dirty blocks here show that this is a live migration and it will eventually be completed. We can also find the thin data ratio alongside all other migration information we need. When I go back to the migration operation, this is now at a waiting stage. Upon reaching this stage, we will receive an email notification, and we can optionally set up an approval window if we decide to start cutover later. But let me just approve it right now for the demo. Once approved, the operation will proceed the rest of the steps. MigrateOps has then prepared compute cutover, where it configured the system to ensure that it had all essential drivers enabled and necessary configurations for our CloudStack instance based on best practices. The operation has proceeded further. Now I have this migration report generated where I can always come back to the reports and view all the detailed information about this migration. As until now, my Windows environment remains live, and the source VM is also still active until we complete the migration session. And looking at CloudStack, the temporary MigrateOps instance is still running with all the drives connected to it. Coming back to the operation, it has shut down the source system to get ready for final transition to the CloudStack instance. From our vSphere client, we can see the machine is powered off, and it is now reconfiguring my migration instance. It is powering off our temporary instance and making all the necessary adjustments. The process is automated. Check this out. When I refresh again, the temporary VM was deleted, and our final STW2K16 SMB production machine is on here, starting. We can see the project P1 and zone Z1 as I previously specified in the YAML configuration. Looking at our volumes, all the temporary volumes are gone, including the previous root 44 disk. And now, this drive 0 is the root disk of our instance as a final result, and it is now running. Once everything turns green, the cutover process is done, and the migration operation is completed. Let me launch the console. My new machine has booted up properly. In the system information, we can see that this is now running as a CloudStack KVM hypervisor with a QEMU virtual CPU with 2 GB of RAM, exactly like how we specified. We also have the virtual I/O SCSI controllers automatically installed in order to run KVM. From the disk management, my 20 GB C drive and the 1 GB EH data drives are all replicated, and they are no longer VMware VMDKs. Instead, they are now virtual I/O SCSI devices. We have successfully got the Windows 2016 server running on CloudStack. Let's have a quick summary of what I did. First, I installed CMC on my host. If you are going with any Linux hosts, the entire migration process is identical. You will just need to use a different installation command when we register. Then after that, I have set up the CloudStack integration. Remember, our migration source can be any environment and any block storage solution, whether physical or virtual, across any hypervisor, private cloud, or public cloud platform. Even older versions of virtual machines from other VMware environments that do not support native migration can be seamlessly migrated using Cirrus Migrate Cloud. Once I did this, I proceeded to create a migration operation configuration in YAML syntax and drag that in Cirrus Data Cloud. Once the operation has started, all the necessary migration and cutover tasks were automatically completed upon confirmation. You might not have followed every detail that was demonstrated, and that's perfectly fine. I basically created a YAML file, submitted it, and Cirrus Data Cloud did all the work automatically. It migrated from my VMware environment to CloudStack. Without any manual interaction, everything is up and running just like before migration. This is how you migrate to Apache CloudStack with Cirrus Migrate Cloud.